Well, hello people. What's up? Hope everything is bright on your side, fellas. So, my name is Darina. I'm a community manager at Lemon.io. If you haven't been familiar with Dilemma.io, be a marketplace where the best talents meet the best clients. We match experienced software developers with the most progressive US and EU-based startups and tech companies. And we decided to make this February the JavaScript Fury months and dedicate 4 events to the JavaScript. We invited the best speaker, Luis, a professional, but I'll keep a secret until he talk about himself, to be a host, to be a speaker, to lead you through this change. The overall duration of the event will be 1 hour. After the talk, you will have an opportunity for questions and receiving answers. So please stay tuned. And the best questions and those who will write the best questions will receive presents from Dilemma.io. And also we will make a draw for those who participated online and stayed with us till the end. So I pass my word to Luis. Hello, Luis. How are you doing?
Now, I hope everybody can hear me and see me, hopefully.
Yeah.
Good. First of all, I would like to thank for the invitation you addressed me to make this presentation. So so let's just move on into the topics. So what I will be talking about is related to reverse engineering topic, but in the context of extending existing applications. So not always we are able to access the source code of the applications we are working with, and this will be a focus on trying to learn on how to leverage JavaScript knowledge to extend those apps. So I'll give you first a quick outline of this presentation. So I'll begin with a motivation for this topic. So it came from a personal story of myself. So then I'll move to some definitions about these topics. I'll also present some tools, briefly, some tools and techniques regarding reverse engineering for web applications. Then specific techniques or specific tools from the JavaScript language that can be used for reverse engineering and extending web applications. Of course, we couldn't talk about this topic about naming some ethical considerations of doing this type of projects. Also talk about the benefits, and then we will give the main conclusions and open a Q&A session. So just to present myself for starters. So I'm a 90s kid, basically. So I was born in 87. So as probably many 90s kids, my interest in software engineering all started with gaming. As a kid, I played many games, and someday I want to build those games. So of course, later on, people that thought about this of doing this, when they get into reality, they know that making games, it's probably one of the most difficult tasks. So I ended up doing other things, but actually I stood quite close to games, but not in the perspective of developing games. So I had my early hacking days even before I started my graduation. So just out of curiosity, and you can see a screenshot here. One of the first things that I did to approximate this domain was ROM hacking, basically. So essentially, I saw some tutorials in the internet on how to use an X editor to open ROMs from old consoles, and I was like editing the texts and making my customized versions. So of course, these were very basic edits, but it was a nice experience to start learning about software engineering. Then I went to college, like many people did. During college, I ended up working on the games domain, but more related to game theory. And when I joined college in Europe, there was there were a couple of changes, and they created the integrated masters. So I ended up doing a master degree. And since the topic did go so well, I also did a PhD right after. While doing so, I started my career as a freelance engineer, working on several different projects in several different languages, not only but including JavaScript, of course. And once I finished, I fully dedicated to software engineering, and I also did teaching. Other roles that I had in the past were related more to the recruitment side of things and management of software development teams. And it was in these last two that that I found the motivation for this topic. And why is that? Well, if you look at all my experiences, there was a common denominator: coding. I was always coding on all my jobs, even those that were non-technical. And the reason for that is that when I took less technical jobs, I found out that there were many repetitive tasks. I mean, I remember like sending template emails or copy pasting information from one place to the other, sending updates to the people I was managing, and to be honest, some of the tools that I was working with were kind of incomplete and very inefficient. So what did I thought? Well, I'm a developer, so why not use my knowledge to leverage my experience in this position? So I made a non-technical position more technical by using coding to extend the application that I was using on those companies to my benefit, so that I would get more efficient doing my work. So so how did I accomplish that? So I had to first reverse engineer those applications, because most of these applications were not open in terms of source code. So I had to check how they worked. And then I took the initiative. Hey, let's extend them. In the case of web applications, I did extensions through browser extensions, which is one of the topics I will talk, and I will give you more details at the end of the presentation. So the outcome for me was more enjoyable work experience, and even in some cases, some of these tweaks that I did on the tools that I was working with were the basis to create future products inside the companies I was working for. So yes, sometimes a small change, like a task that you're repeating all the time, what we do as developers is to make those tasks more efficient. So why not do it for us? So my main motivation is to try to have my fellow friends and developers to use their coding experience not only for developing apps, but actually as well for their own tasks, maybe other jobs they have, maybe personal tasks they are doing all the time. Why not use coding, right? So since we have the skill. So this is the context and why I'm talking about these topics. So I'll move to the next slide. So basically, I'll start with some definitions. So before we extend an app, we need to reverse engineer. So what does it mean? It means understanding basically understanding how it works. So try to replicate the inner workings, see how it was built, learn what how the app communicates with other services, and all of that. So basically, try to understand an application without having access to the source code. So this has many applications, and a lot of a lot of people do reverse engineering for different purposes. For instance, for web crawlers, sometimes we need to reverse engineer the way the app works, so that we can crawl the information in a better way. Or to do integrations. Let's say we have an older software without an open API or without documentation, and sometimes we need to integrate with this software. So we need to figure out how it works, and especially for this is especially true for older softwares. So we can also do it for monitoring purposes, for learning. This is one of the benefits. So sometimes we can try to reverse engineer an app to see how a certain solution was done by other people. Also for documentation purposes, for studying security, and sometimes even for on a cost perspective. So speaking of the cost perspective, so this is something I usually talk about. So I'm also a teacher currently, and this is something I talk about a lot. So in every single company, there's a very delicate, or there should be a very delicate balance between the business and the engineering side. So because probably a lot of you wanted to do a functionality or a code in a certain way, and you simply didn't have the time, or you didn't even have the market fit proven for that functionality that would justify spending all the time doing the best possible engineering. Not to mention that the best possible engineering today will be different tomorrow, because requirements will change. So there must be a balance, and I found out through my experience that sometimes reverse engineering can contribute to this balance as well. So when we want to quickly, I can give you a quick example of, for instance, one of my clients, we were testing some layout changes, and I was using the browser DevTools to edit some of the colors live to the client before making the changes and publish them. So the client could see how it looks live. So this is, of course, this is not purely reverse engineering, but it's a way. It's changing the app on the fly to test out if it makes sense to do the investment. So now I'll talk about the tools. So one of the tools I already talked to you, I already mentioned. So the browser dev tools. I mean, this is the most basic tool that everyone has, and most of the web browsers, modern web browsers have, which is the browser dev tools that we can use to help us with reverse engineering tasks. So of course, it offers several functionalities like inspection and debugging capabilities. We can check all the network requests and the data that is being responded from the services we are consulting. We can see the source code from JavaScript. We can also see the HTML and the live and the current DOM that the page is rendering. We can also debug the code. So there are many things we can do, and I mean, I will name a couple of tools during this presentation, but this one is typically enough to at least start doing something. So one type of tools that we typically do for this kind of work for reverse engineering is, of course, network analysis. So basically, a lot of the web applications communicate with APIs. So we send requests, we receive responses. So and analyzing the information that goes through the requests and see the information we are getting from the servers help us understand how the app works. So there are a couple of tools that you can use other than the web browser inbuilt tools. For instance, I use sometimes Fiddler, which is a web debugging proxy tool that captures the traffic between a client and the server. TCDump, which is a very basic command line network pack analyzer that most operating systems have. So, of course, there's a requirement for using these tools, which is, of course, we need to understand the basic protocols like HTTP. Otherwise, it will get a bit more difficult to understand how the applications work. So basic understanding of HTTP would be essential to use these kind of tools. There are also a different set of tools which are more related to the compilation and decryption of the code. So in the case of web, we even though there are some solutions, typically the code is not compiled per se. I mean, it's obfuscated, it's simplified, it's minified, and it's there's even a tool you probably a lot of you know, Uglify, that uglifies the code to make it less perceptible and make it harder actually to reverse engineer. But there are tools that do the exact opposite. So basically, they are focused on trying to restore the code to the original state. Of course, there are some limitations on those tools, and I will give you an example in the next slides. We also have code analysis tools, which will allow you to analyze the source code of web applications automatically and extract insights about the structure and logic. So this includes debugging and testing. So sometimes debuggers can also help us, especially on a language like JavaScript, which is single-threaded. Those tools will help us see where we are right now, analyze the memory, and try to understand how the application works. Okay, so of course, to use these tools, we need a comprehensive understanding of web application development. What is the role of JavaScript, since the big topic is JavaScript? So, well, for starters, it's used in most. I strike through all because there are very, very few exceptions, but in most web applications we are seeing JavaScript one way or another. Of course, JavaScript is a very good language because it has been evolving a lot. I mean, for someone that used to code in the 90s, JavaScript has come a very long way and adopting many more features that we are using these days. So it's, of course, widely used and well documented. The fact that it's dynamic and interpreted makes it also easier. And I'll give you a couple of examples on why is that. Of course, one of the features that makes it easier is it allows for patching, so we can kind of replace or functionality, since it's interpreted on a live perspective. So you can just change the behavior of existing functions for the purpose of reverse engineering. And JavaScript can be used for manipulating the document object model, so basically the interface of the web application. Now I will go for some of the specific features that can really aid reverse engineering. So I will list a few, and then I will give you concrete examples on the characteristics of the JavaScript language that we can use to help with reverse engineering applications. So first of all, the debugging tools. We have the debugger statement, and of course the console API. So those are the most basic tools. The dynamic code evaluation. So the eval function is very powerful, also very dangerous if not used carefully. We also have reflect API or get on property descriptors methods. These methods can be very useful when reversing in engineering the behavior of certain objects. Of course, decompilation. It's not, as I mentioned, the code is not actually compiled. It just changed to look different and look minimal. But there are tools that can help you get a more proximate version to the original one. Of course, the analysis of the DOM is essential. I mean, we need to analyze the web interface in order to try to understand how the functionality works. This has, of course, this has been getting a bit more difficult in the last years. Well, due to the appearance of the single-page application frameworks, of course, since the DOM is changes a lot more with those frameworks and libraries like React, Angular, and so on. It gets a bit more difficult, but it's still possible to use DOM manipulation to try to understand how the apps work. Other things that we have. So we have built-in observers in the JavaScript language, like the Mutation Observer. We can manipulate the fetch API or the XML HTTP request object to try to intercept network requests between the application and the APIs it's accessing. We also have the console trace method, which can list us some very useful information about certain part of the code that is running. We have more advanced techniques like heap spraying or code injection into the web applications that also can help us achieve some good results. The code injection more towards extending the applications, but yeah. So and finally, we also have the good old pooling for DOM changes, which can be useful in some cases. So I will move to some specific examples of each. So regarding the debugger statement. Let's say that we have an existing function. So we can one of the things that we can try to do. Let's say that this function was not developed by us. It was already existed in the application somewhere. So one of the things that let's say that we want to know when the function is called. A good possibility is to use the debugger keyword in JavaScript. So basically, we created a function that will replace the original one. So basically, we are replacing the original function, but adding a couple of instructions. So we use the apply to apply the arguments to the original function. but we launch the debugger once the injected function is called. So this can be helpful when we want to stop the application once a certain function that we are trying to learn how it operates is launched. So moving to the next one, so the eval. So eval, this has been around for quite a while. So it's a very powerful function that basically takes a string and runs and interprets the code in that string and runs the JavaScript and retrieves the result. So it basically does dynamic evaluation of JavaScript code. It can be used to quickly evaluate changes, and be careful with this one because it can run literally anything. So it can be used to inject malicious code as well. So we have an example in this case, I'm extending or changing the behavior of an existing function. So basically, let's say that we had this function that returned the sum of two variables. I want to return the result to the power of 2. So basically, I'm actually changing a part of the code of that function, and we can do it by converting the function to a string. So basically, we can interact and change dynamically the code of the function, and then I'm evaluating. I'm calling eval to evaluate the result of the function for demonstration purposes. So this is a very flexible way of trying new functionalities and trying to extend the applications. So this is an interesting one. The Reflect API. So basically, it allows us to retrieve dynamically a certain field or function from an object. Regarding the get-own property descriptors, so basically this function that is in built JavaScript will retrieve a list of all fields that the object has, and some characteristics of those fields. So basically, this will allow us to understand the structure of the object, and of course also call and retrieve the values for those fields. This is a very way to get a very comprehensive description of the object that we are analyzing. So one thing to assume, of course, is that all these objects that I'm instantiating here. So basically, we need to assume that they are already in the app somewhere. So the idea is not to use these with an object that we already know, but rather with an object that is somewhere in the application. Okay, so I guess we had a couple of questions. I can.
The first one is from Beata. What kind of debugger was used in the previous example?
Let me. So you mean on the slide about the debugger statement?
Beata, if you hear us, could you please write a comment if it's in the slide?
So yeah, it's the browser debugger basically. So it will launch the browser debugger if you have that instruction there.
Beat answered on the first example.
Yeah.
Okay. Is there any additional questions or comments for now? If so, just let us know so we can answer it right now.
Yes, feel free to.
Okay,
Okay, let's
move on.
move on. I will also answer questions at the end of the presentation, so we can move some of those to the end if needed. So so we were here. So this is probably one of the most interesting ones that I personally used quite a lot to reverse engineer. So because this kind of is a way to observe a certain object and try to observe when there are interactions with that object. So let's say that we have an object that has the property ABC. So with this function define property from the object class, we can redefine the setters and the getters for the access of that property. Of course, here I'm altering the setter. So basically, what I'm doing here is that whenever someone sets the ABC property, I'm logging a message. I mean, I'm logging a message. It could be anything else entirely. So you can insert whatever code you want. So you probably have noticed that I have these checks at the beginning of the function. So basically, and that's why I created an inline function that returns the function that will be used as handler, because I needed this local variable b. So basically, this will prevent the recursion, because when we are doing a setter, the setter will need to set to reset the variable ABC to the new value, because if we remove this behavior, we will the setter will work in a different way. So basically, when we do this, it will call recursively the setter again. So basically, I'm doing this check to avoid the recursion. This doesn't work in all cases, because we don't know if the setter was already modified, but there are ways to access modified setters as well. So this is really, really helpful whenever to check live interactions with the objects that you are observing. So I will move on. So regarding the compilation, so the compilation, as you know, a lot of the code that we use is uglified, is minified. So if you go to an on-production app, most likely you will not have access to the original code, even though we still see that mistake often. But there are ways to try to get it back as close as possible to the original. So we have JS Beautify. There are other tools. This is a simple one that I sometimes use. Of course, this has a big limitation. So you can restore code semantics. A lot of the semantic of the code that we write is on the naming of the functions, naming of the variables, and there is no way to recreate those names. So it will make the code more imperceptible, just because of that, because we will lose the semantic of the algorithm. Of course, there's still the benefit, even if we don't have the original names, that we can analyze the flow. So what is happening, even though we will have a much more hard time to understand the algorithm since we don't have the original variable names. So just to get some of the comments that you are sending. Yes, websites, of course, with Angular make it harder to decode. Any SPA framework will make it harder to understand the original code and how the application works. Dimitro, I will address the reflect again at the end of the presentation. And Francesco, regarding live demonstration, so this is actually on the plans for the next presentation. So this first presentation is more towards the theoretical knowledge and some practical examples, but we will do live reverse engineering on the next one. So this was left to the purposely to the next presentations. So I'll continue. I'll move forward. So the DOM API. Of course, manipulating the DOM is very basic thing to do when trying to understand how an app works. So I have here a concrete example. So this is from Twitter. So this is the interface from Twitter from a tweet that I extracted. And basically, in order for us to extract information, we need to analyze the HTML and the DOM very carefully, and more and more it gets way more difficult. I know that this isn't very visible because it's this DOM is already compacted and there's a lot of divs, but we now have frameworks and libraries that generate CSS classes. So this will always be different, and it makes it harder and harder to retrieve information from these applications. But it's still possible. We just need to try to find the unique aspects of the elements that make them selectable. So in this case, I found this data test ID attribute that was equal to tweet text. I found this attribute, and when I was analyzing Twitter's DOM, and it was common that in every tweet it did appear in the HTML. So I used that to select the articles and the text from the articles. So this is an example. This is an example code that you can actually use to get an array of all the text of an array where each position is the text of a tweet. So, and it does exclude the replies to tweets. So with this instruction, not has article. Again, this is very useful for us to retrieve the. There's a lot of work when we are trying to extend an app to understand the DOM, because there are situations, for instance, when we are developing a Chrome extension, and Chrome extensions can be Chrome or browser extensions can be used to, for instance, insert certain elements in the page. We need to understand the DOM to know where to insert those elements. So I'll move to the next one. Mutation Observer. This is also a very interesting one that can be very helpful for us to use. So I have so basically it's an observer. It uses the observer pattern to detect changes in the DOM. So let's say that we had a navvar in this specific example, and we had this function that checks the navvar and detects if the navvar is expanded or not. So we can create a mutation observer. In this case, the mutation observer is only printing expanded or not expanded, but again, we can do any functionality that we like. But so basically, in order to make this work, I just had to create this mutation observer, use the query selector to select the navvar, and we are watching all the attributes. So anytime the navvar changes its attributes, this handler will be called, and this can be very useful for us to know when certain interactions are made with the interface. Once we are done, or we don't need the observer anymore, we can disconnect this. So this can be these kind of observers can be very well used with, for instance, with a React hook use effect. They work really well to detect certain DOM changes. Of course, the API is way more complete than this. So I'm just checking for attributes in this case, but you can check for other types of changes, and this will work. So another thing that I personally used for trying to understand how apps work is to change or modify the native objects. So we have this object, XML HTTP request, that basically is the object behind the AJAX request that we do to APIs. And I'm basically changing its original behavior. So I stored the send function. The send function sends a request as the original send. And then before, and the new send function will basically do some changes to the request. In this case, I'm creating or modifying the var foo inside the body of the request to be bar. But you can, for instance, just log that the request is being done and with which body this, again, can be useful for you to understand. You can check the type of request. I mean, this is being applied to all requests, but you can do only for certain requests. You can also do this with the responses objects as well, because anytime you do a request, this object will be used. So it's a good way for you to try to reverse engineer the communication between the client side and the server side. Another good instruction that you can use, console trace. So this method can be used to trace the call stack of a function. So this is an example of output. If we again, I showed you that we can inject code by replacing the prototype of the function, or by using eval, or by using any other means, or by changing the code through the string of the code. So if we have for instance, if we have the console trace to the beginning of the call, we can, for instance, know when the function is called and from where it's called. So this can be also very useful. Of course, this can also be achieved through the debugger, even though sometimes if the code is too obfuscated, it can be a bit more difficult, but still possible. So another thing that we can do, coding injection. So this is the basis of many browser extensions. So basically, we try to we inject a script. So if we are building an extension that extends the functionality of a web application, we will need to insert a script tag with a code that we want to run on that website. So basically, this is a way of doing so. We basically just need to append a script tag with a code with a string where the text is the string of code that we want to run on that web application. So this is a more basic technique, but also useful in some cases, which is basically pooling the DOM. So sometimes, and with dynamic web applications that use Angular, React, Vue.js, or other frameworks, I mean, the DOM is always changing, and sometimes things have changed quite a while in the last, quite a bit in the last 10 years. So basically, when you will load an application, it's always changing, and you don't have guarantee that a certain element that you want to watch or modify is available. It's a very simple technique to do that is to pull the DOM. So try to select the element or the attribute every X minutes, every X seconds or X milliseconds, and once ready, we can do whatever interaction we want. So you can achieve this with a set interval method that probably most of you know, but which will repeat until we clear the interval. So whenever the query selector provides me a result, I will clear the interval and do whatever with the value. So this I will on one of my next presentations, I will give you a specific example where this was very, very useful for an application that I extended. So I don't have more examples for today, so I'll move to more an important topic regarding reverse engineering, which we should always take into account. So even before we start, we need to see, can we do it, or is it safe to do it, or is it going to infringe any copyright or any license agreements or contracts, or because with the, I mean, reverse engineering in a way is a nice way to say hacking. Hacking is reverse engineering, right? So basically, by using some of these techniques, we can access information or access functionalities that probably we were not meant to access. I mean, from a ethical perspective, even if let's say there's a flaw in the app, a security flaw, of course we shouldn't access that information or that functionality because it's not meant. Just because we can, it doesn't mean we should, right? So there are some laws towards this. So from what I know about this topic is that there were some cases of disputes, of legal disputes, and sometimes it's not clear if the reverse engineering that we are doing, in case we are doing over a third-party app, because that doesn't need to be the case all the time. It's malicious, or it was. So there were cases where it was solved in favor of the engineer, and other cases where it was decided on behalf of the company that served the software that was reverse engineered. I mean, typically, in most cases where it's solved in favor of the company is when there is any kind of copyright infringement or data violation. Um, so the other cases are a bit more difficult to anticipate. In any case, there are, of course, non-malicious or reverse engineering with good intent. For instance, you can do it for the company you are working for. So you can try to have one or two members of your team try to reverse engineer the app you're doing to see if there is any security flaw. So that's perfectly acceptable. So if done inside the company. So of course, again, I'm not a legal expert, but I know that there are many different interpretations and laws throughout the world regarding this. But it's our responsibility as engineers to first review the terms of use of the application. I mean, if even we should, if we are using a certain application, it's fair that we both if there's an agreement I'm using, I need to agree with the agreement, right? So otherwise I don't use it. So, and if the agreement of using the application says, hey, you should only use applications in the way it's meant to be used, you shouldn't reverse engineer, ethically speaking, of course. So in case you are in doubt, you should seek legal advice. Of course, this is not a very easy topic where there's a lot of there's a lot of different versions between countries. So it will be difficult to get advice, but you should in case you are in doubt. One of the main things is always to respect proprietary rights and intellectual property. So reverse engineering shouldn't mean getting access to proprietary information. So that's a big ethical no. And for the sake of transparency, anything that you do, especially if it's a third-party platform, document all the process. Document what you did for transparency. So and for your own record. So this is something we should always do. Of course, it's not all problems. We also have some benefits. So as I talked earlier in the presentation, so there's the balance between engineering and business. So sometimes we can use reverse engineering to test quick changes or to do non-malicious improvements for ourselves. Again, if we're not accessing other people's proprietary information, that should be fine. Of course, we shouldn't use to avoid licensing fees. For instance, for streaming applications, there are a lot of people trying to, download the media, reverse engineer to download the media, like from Spotify, Netflix, try to download the movies. So of course, this is a big no because we're trying to avoid license fees, and again, those platforms were not made for us to download and use the media elsewhere. It's to use inside the app. Other benefits can improve efficiency in development teams and also the security of the applications we are developing. Essentially, by learning how to make our applications reverse engineering proof. It's not entirely possible, but there are ways to make it more and more difficult, and people do invest a lot in making it more difficult. On the costs side, so this is this is something that I follow. So I use reverse engineering to test market fit as well. So to do some quick changes and to see some quick gains in order to try to leverage that knowledge to see if it was worth implementing the idea. So, and in some cases, it could be faster by extending apps, and thus evaluating demand and potential improvement for existing products. This can also be good for changes in old applications. So there are applications that are already abandoned, so we don't have access to the source code anymore. So they are really old, and there are actually I know a concrete example where there was a successful reverse engineering project where they were trying. A company that I worked with a long time ago, we reverse engineered a Windows application, Windows desktop application to a web app. So this was not inside the web, but it's an example of a successful project. And with again knowledge of how the app worked, we could recreate a new and superior version of the product. So it was all inside the company, so no legal issues. But we can also have sometimes ethical dilemmas in reverse engineering. For instance, this history, it's a real history. So it's a company that reverse engineer an existing medical device, and when they acted, they saw that the original version could endanger patients' lives. So what to do in this case? So I was researching an existing product, and I found out that it could be dangerous. So should I profit by selling the new version? Of course, it's kind of unethical because it came from an already existing product. But or should I tell this to the general public and harm the financial interests of that company? So yeah, it's always a difficult decision to do, but these cases do happen. So as a conclusion for my talk today, is it worth learning how to reverse engineering? I think so, but I would like to hear some of your thoughts after the end of the presentation. So I'll just do a quick recap. First, I gave you an overview of what reverse engineering was, how some JavaScript, I explained and I gave you example of some JavaScript traits that you can use for reverse engineering. I also gave you a brief of ethical considerations and legal implications and responsibilities of reverse engineering, the financial impact of reverse engineering, both on the engineer and the product that is being reverse engineered, and some examples of projects. So some as final thoughts. So it's important to understand. It's important to reinforce understanding of real reverse engineering in the context of web development, because a great deal of the applications we use right now are in the web. So we need to know when it's ethical and unethical to do so. So it has the potential to unlock new opportunities and solve problems. Of course, we always need to consider the implications. But still, I think overall, this is something that will never go away. This is something we have been doing since there is software. We always try to recreate and replicate how things work, and this will not go away, not in the upcoming years. So, and of course, there's a growing demand. Of course, in order to do a proper reverse engineering, you need to be very good with the technology. So you need to be a step above. Typically, it requires some seniority. some seniority to do so. But again, you should try at least some of the simple examples that I gave you today. So just to give a quick summary on the next talk. So I will go deep on the patching on Monkey Patch on JavaScript. So I gave you an example on the requests. So basically changing the behavior of a function, and we will talk about that with more practical examples on the next session. Then we will talk about browser extensions and how to create simple browser extensions and then afterwards we will create we will adapt browser extensions to extend existing web applications. So this was it. Thank you very much for assisting, and I'm open to all your questions.
So thank you, Luis, for a great talk. I hope the developers who joined us today could benefit from it. And let's start from the questions. We received a question from Beata. She asks, is there a way to track the person who got access to tracking GS from website inspection?
If there's a way to track, yes. I mean, I'm assuming tracking JS is just some library that you have on the web application. One of the ways of doing so is to log. I mean, it depends, because a lot of applications just pack every JS file, so you might not even have that file. But there are a couple of ways to track, but that must be done on the server side, so not through reverse engineering. I hope this answers your question. So,
thank you. Beata, let us know if you have any additional questions, and let's move on to the next one from Carl. You said several times that the eval function is potentially dangerous, leaving your code vulnerable to malicious code. Can you go into more detail how it's dangerous or exploited?
I mean, because eval does allow you to insert any code, so there is no verification. So you can, for instance, eval a function to read your client side information and send it to some other application or server. So of course there are some cross-browser protection, but still it can be used for literally running any JavaScript. Eval was used because on the browser URL you can actually insert JavaScript instructions. And some of those can use eval. So it's dangerous in that perspective, because if you copy paste the code or if you bookmark some code that uses the eval function, it can lead to dangerous code injection into the application you're using.
Okay. Can we move to the next question, Luis?
I guess so.
Okay. Carl, let us know if we answered your questions. Please write down in the comments. And meanwhile, we will move to Andre comment. Andre saying thank you for the great presentation, and asking, have you tried to use GPT like AI tools to recreate variable function naming after using the compilation tools like JS Beautifier? If so, were they helpful?
Actually, I didn't try it, to be honest, but I think that's a very interesting idea. I mean, I guess that maybe GPT can recreate some of the semantics. Maybe it will be useful to insert other parts of the code as well to extract the semantic from there. But I mean, the GPT is very good at understanding semantics. So I guess so. It can be potentially used. That's actually a very good idea. I didn't try it myself, but thanks for suggesting that.
And thank you for the interesting question, Andre. Okay, let's move on. The other question from Andrew. Have you ever run into legal implications from reverse engineering web applications, especially when REing apps for your clients?
No, not actually, because I always asked for permissions. I didn't ever had any issues myself, fortunately, and I used. I mean, I of course tried in some third-party applications only for personal use, but never accessed any internal information or anything like that. So fortunately, no, I never run into any issues. And actually, one of the clients where I used that on a managing role, they were very happy that I did so, because that led to a very interesting extension of the behavior of the platform that ended up turning into a product actually. So it was very interesting story. I will tell you that story on the next presentation.
Okay, so stay tuned.
Yeah.
Join us next week on Wednesday at the same time, 7:30, 17:30, 5:30 p.m. We will send the invitation. Okay, let's move on to the next question from Deepti. Let's say we figure out the version of JS libraries and frameworks using some tools in browser, which we use during reverse engineering. Is there any way we can further break it down?
Yes. One of the things that I did. So one thing that we can remember is that the JavaScript does use a global spec, so everything is accessible one way or another. One of the things that I did, for instance, was if I was searching, for instance, for a version or something like that, I can use recursive functions to expand on the objects and try to find attributes with that name. So yeah, essentially that's very much possible. Another thing that you can do. So typically, the HTML elements, and you can use the browser inspector for that. They when they are generated by React or Angular, they have internal information added to their prototype that from React or Angular that allows you to then access the data that comes from those libraries or frameworks. So it's a good way to retrieve that information. So it's typically not too easy, but one thing that you can do, again, this is something I will also address on the Chrome presentation, on the browser extension presentation. But essentially, you can go to the inspector, select an element, right-click on the element, store as a variable, and then you can explore that variable that is generated on your console. And there you will find React or Angular or whatever framework associations of that element with a framework or library, which will allow you to go deep further into exploring it.
Great. And let's move on to the last question from Beata. Can you expand on SPA websites, how they make it harder to inspect and re-engineer?
Because one of the reasons is that the DOM is always changing, right? So like 15 years ago, you would get a very fixed DOM. There were no DOM changes. There was barely JavaScript in the websites, and I mean, and Another thing is that there's these frameworks and libraries use their own virtual DOM. And the DOM that you see and that you have access, more direct access, is generated by that virtual DOM. So of course that can make it harder because you are reverse engineering something, and the way the application was coded is different than what appears on the DOM. So since there is this abstraction, it makes it harder to understand how things work inside those apps. And again, I can also refer the other example that I mentioned regarding the regarding pulling the DOM to retrieve a certain element that is not ready yet, because we don't know, we don't have access, direct access to the logic of transforming components into DOM. Okay.
Great. So I think we are done with questions for now. We've got plenty of them, and I hope we covered them all. Luis, I propose you to choose the most tricky, the most interesting question, so the person who addressed it could receive a prize. And meanwhile, I want to invite you to the following events within the JavaScript Fury months. Each Wednesday, we will conduct a meetup with Luis and we'll discover the topic. If you have any questions or suggestions or feedback for this meetup, please tell me about it. I'll write down my email. We will appreciate it. And Luis, so what do you think? Any ideas on the best?
I really enjoyed I enjoyed all the questions. I think I really liked the question from I'm not sure if I'm pronouncing correctly, so I'm sorry if I don't do it, from Deepti about broke it down even more regarding the browser version and the frameworks version. So I really enjoyed that question.
Cool. Deepti, if you're still here, please write to the email dnifomova limon.io. And also, I made a draw while you were talking, Luis, and we have the other winner, just the randomizer. It's Carl Hikerson. Also, correct me if I'm wrong with the spelling. And we have two winners today. You will receive a special prize from the Lemon IO, and we hope you enjoyed the talk. And see you next week. Deepti and Carl, please. I'll reach you out or just ping me. Awesome. Thank you all. Have a beautiful evening and see you.